Hi all. So let's start. Now this is very important topic, that is distributing objects into boxes. So let's start this. What this means? This means you have some objects and you have to just distribute them in the boxes. Let me tell you that there are some templates. We want to distribute objects into boxes. For example, let's assume your objects are these. And let's assume that your boxes are these. So your boxes are, so these are the boxes. So tell me, how many ways you can distribute? I want to distribute all these objects into these boxes. So like there are two boxes, different boxes. So basically here we have what we have. Here we have different objects, different boxes. Yes or no? Objects are different, A, B, C, D. Objects are different and boxes are different. So this is called DODB, means different objects, different boxes. This simply means different objects, different boxes. Okay, so tell me now, how many ways you can distribute? For every object, how many ways you have? For every object can go to either B1 or B2. This object can go to 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 B1 or B2. So for every object, you have two choices. So the answer will be 2 power 4. It will not be 4 power 2. Don't do 4 power 2. This is correct. Okay, this is correct. Don't do this. Like this is a coincidence. I think that they are same. This is a coincidence here. But anyway, this is 2 power 4 because for every object, you have two choices that can go to B1 or B2. Now here you can notice you have different objects, different boxes. So here what matters? In this problem, what matters? For example, this is your B1, this is your B2. Are they same? If I do like A, B, C, D, C, D, A, B, are they same or different? These two are different, right? These two are different, correct? Okay, these two are not same, these two are different. Now let's see another scenario. Another scenario is I will take identical objects. So objects are identical. All the objects are same, but boxes are different. So you have identical objects like A, 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 A. Okay, and boxes are different. Now in this situation, you tell me, okay, what will matter now? What will matter? Now you can notice only this number will matter. Like here you put 0 and here you put all the 4 because the objects are all identical. Yes or no? The objects are all identical. So only these numbers will matter. Okay, like you put 1A here, 3A here. You put 2A here, 2A here, 3A here, 1A here. Are they same or different? This and this, are they same or different? They are different because boxes are different. Identical objects but different boxes. Like let's assume this is a child. Let's assume this is Sonu and this is Monu. And these are chocolates. Let's assume these are chocolates. Then you can notice that here in this scenario, Sonu has 1 chocolate. Here Sonu has 3 chocolates. So they are different. And finally, okay, you give all 4 chocolate to him. So there are 4 ways. And here we have total 16 ways. Okay, so when you have different objects, different boxes, then you have 16 ways. And if you have identical object, different boxes, your objects are identical, like chocolates. You have chocolates. Okay, these chocolates you are giving to Sonu, Monu. So different boxes. Okay, so only these numbers will matter. Yes or no? Only these numbers will matter. Like how much number you are putting to B1. What number you are putting to B1, this number will matter. Yes or no? This number matters, correct? Only this number matters. But here you can notice this number will also matter and which element, that also matters. Yes or no? This number, like these are different. So number is also important and which element you are putting, that is also important. Is this clear to everyone? So here you can notice these are different. These are not same. All of them are different. Now the next scenario is DOIB. Means objects are different. It means objects are different. So let's assume objects are like ABC. These are your objects ABCD. But boxes are same now. Boxes are same. It's like a hotel. In a hotel, you have same room. All the room are same. Yes or no? In hotels, most of the time, all the rooms are same. You can take any room. It does not matter. Like all the rooms have the same price. All the rooms, they have same price. Like let's assume every room has, 2000 price. So you can notice in a hotel, the rooms are same. Like room number 1, room number 2. So you have two rooms. Both are same. R, R. So your object, so I can say DOIB means your boxes are same. Your boxes are same. Because your boxes are same, so you tell me, because your boxes are same, are these two things same or different? You put AB here, CD here, you put CD here, AB here. Are these two things same or different? These are same, right? It's like this. Okay, these are friends. Just consider like this. These are friends. They are going on a picnic. These are friends. They are going on a trip. And these are the rooms in a hotel. These are the rooms in a hotel. So what this scenario means, what this scenario tells you, this scenario tells you that AB are together, CD are together. AB are together, CD are together. And this scenario also means AB together, CD together. So these two scenarios are same. Yes or no? These two scenarios same. Next, you tell me, are these two scenarios same? This and this. DC, BA. Are these two same? Yes, these are also same because these are distribution. In a distribution, order does not matter. Remember, in a distribution, order does not matter. For example, here, in this scenario, you notice, are they same? Are they same? DC, BA. Are they same? Yes, they are same. Because you are putting elements in the object. You are putting objects into boxes. So when you are putting objects into boxes, the order does not matter. The order of elements does not matter. Okay, so this is the idea. So this is your DOIB. In this DOIB, you can notice AB, CD. These are same and these are same. So tell me how many possibilities you can create. Are they same? Like A, B, C, D. These are they same? Are they same? They are different. They are different. Why they are different? Because you can notice here A is alone and here B is alone. Yes or no? In this situation, A is alone. In this situation, B is alone. If this is a haunted movie, who will die? If this is a haunted movie, then in this scenario, A will die. In this scenario, B will die. Okay, so very simple. This is the rule of haunted movie. Okay, like the rule book of haunted movie that says, if you are hero, you will die. Okay, like if you are logical, you will die. In a haunted movie, okay, I just want to share one thing. Like whenever you are watching a haunted movie, and let's assume there is a character, and that character is like, okay, there is no like that character is behaving like this. Okay, that there is no ghost. Okay, don't worry. Okay, I will go alone. Then what we think? Our psychology is that we will think, okay, he's an idiot. But in the real life, he's the logical person. Okay, so idiot of a haunted movie is you in real life. You just check it. Okay, the person who we call idiot in a haunted movie, that person is actual person in the real life. Like you will behave the same in the real life. Okay, anyway, let's move on. So let's see the next IOIB. What is that? IOIB. So what is this? This is identical objects, identical boxes. Everything is same. Like your objects are like your objects are A, 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 and your boxes are R, R, like this. Okay. So in this situation, actually, you can notice these are different, right? These are different. Okay. For example, this is also different. A and B, C and ABD. These are also different. So like this, you can create. Now you have objects are also same and boxes are also same. So how many you can create? Tell me, is it same as this? Are they same? Are they same? Yes, they are same, right? Because objects are also same and boxes are also same. So how many difference you can create? Like, okay, I can count this. What else I can do? What else I can do? I don't put anything here. I put all the 4 here. This is also correct. Or what I do? I put, or what I do? Can I do this? Like, okay, so I can put 0, 1. I can put 2 here, 2 here. Is there anything else I can do? Is there anything else I can do, or only 3? Yes, only 3. The answer will be 3. So for this situation, the answer, what answer you will get? Answer will be 3. Because only 3 you can create. Either all the 4 here, 3 here, 2 here. Now remember, you cannot create anything else. There is nothing else is possible. Now one by one we will study all the templates. So but did you understand all the 4 templates? All the 4 templates, did you understand? Like what is the difference between them? All the 4 templates, total 4 templates we have. Now let's start with the first template, that is DODB. It simply means different object, different boxes. Distinguishable means different. Okay, this DODB template is the most simple template. This is the most simple. Okay, there is nothing more simple than this. This is your normal product rule with combination. This is the product rule. You apply the product rule with the combination. This is your DODB template. Very simple. For example, solve this question. How many ways are there to distribute hands of 5 cards to each of the 4 players from a standard deck of 52 cards? What will be the answer? So what will be the answer? This is your, remember, this is DODB. Yes or no? Why this is DODB? First of all, what is the template? First you tell me what is the template. Template is DODB. DODB. Because for people, players are always different. So these boxes are different. These are your boxes which are different, because players are always different. People are always different. So your boxes are different. And all the 52 cards are also different. These objects are also different. So this is your template, DODB. Now this template is very simple. This is your normal product rule with combination. So total 5 players you have, 4 players. Okay, like 4 players, A, B, C, D. These are the 4 players. Then what I can do? From 52 cards, I can select 5 cards and I can give to A. Yes or no? This is what I can do. Yes or no? From 52 cards, I want to give 5 cards to A, 5 cards to B. I want to give 5 cards to him, 5 cards to him, 5 cards to him, 5 cards to him. So what I can do, very simple. From 52 cards, I can select 5 cards. I can give them to A. So to A, I will give them. Next, from the remaining, I will select 5 cards. I will give to B. This is what I will give. I will give to B. From the remaining, I will select 5 cards and I will give to whom? I will give to C. And from the remaining, I will select 5 cards and I give to D. This is your answer. Yes or no? This is the answer. Is this clear to everyone? So very simple. Okay, because you have total 52 cards. From 52 cards, you can select 5 cards, you can give to A. Like in front of you, there are A, B, C, D in front of you. So 5 cards, give to A. 5 cards from the remaining 5 cards, give to B. From the remaining 5 cards, give to C. From the remaining 5 cards, give to D. This is your answer. If you solve it, then what will you get? Just solve it. What will you get? If you solve it, let me tell you what will you get. You will get 52 factorial divided by 5 factorial, 5 factorial, 5 factorial, 5 factorial, 32 factorial. This is what you will get if you solve it. If you solve it, this is what you will get. 52 factorial divided by 5 factorial, 5 factorial, 5 factorial, 5 factorial, 32 factorial. Why this you are getting? Why this is what you are getting? See, because it's like this. You have total 52 cards. Total 52 cards you have. And these are the boxes A, B, C, D. You want to give 5 to him, 5 to him, 5 to him, 5 to him. Just consider like this. Just consider like this. And this is trash. Okay, this is trash. This is a trash. And to this trash, you give how many cards? How many cards are you giving to this trash? 32 cards. Okay, so very simple. 5 cards, 5 cards, 5 cards, 5 cards, 32 cards. So finally, can I treat? Okay, remember, order will matter here. Can I say here order will matter? Like I am giving 5 cards, will order matter? I am giving 5 cards, will order matter? No. So what I can do, I can consider like this. What I can do, I can consider like this, that these 5 cards I can consider as A. Like these are the cards of A. These 5 cards I can consider as B. Because order does not matter. Okay, order does not matter. Order doesn't matter. We don't, okay, when you play a card game, order doesn't matter, right? The order doesn't matter. So I can consider these 5 cards and that these are the cards of A. These are the cards of A. Okay, so on every card I can mark A. Yes or no? I can signature. I can give a signature A. And these cards B. And these cards C. And these cards D. And these cards, what about these cards? Trash. So finally, okay, what is your answer? Your answer is very simple. Basically, it is 52 factorial divided by 5 factorial, 5 factorial, 5 factorial, 5 factorial, 32 factorial. Okay, like this you can do. Anyway, okay, basically you just have to understand this method. This method you have to understand. Is this clear to everyone? Tell me. Is it clear? Now, let me ask you one question, and this is important. Most common mistake in, this is a note, and this note is most common mistake in DODB. What is the most common mistake in DODB template? Most common mistake in DODB template. In this DODB template, what is the most common mistake? Okay, so let's see this template. In this template, this mistake students will make. So what is the mistake that students will make? This one. That, for example, let me give you a question. Let's assume you have total 6 elements. Okay, you have total 6 elements A, B, C, D. These 6 elements you have A, B, C, D, E, F. And let's assume you have total 3 boxes. 3 boxes. Let's assume box number X, box number Y, box number Z. Now what you want to do, this is what you want to do. To this X, I want to give two items to each. Okay, there are total 6, and I want to give to everyone, I want to give to everyone 2 items. To everyone I want to give 2 elements each. Okay, this is what I want to do. Then what will be the answer? What will be the answer? I want to give 2 elements to each. Then see, this is okay. What is wrong with this logic? Please tell me what is wrong with this logic. From 3 people, I select one person. From 3 people, I select one person to whom I give 2 elements. Okay, from 3 people, I select one person. To this one person, I give 2 elements. From the remaining 2 people, I select one person and I give, from the remaining, I give 2 elements. And then finally 2C2. What is wrong with this? Can anyone tell me what is wrong with this? What I'm doing? Are you getting what I'm saying? Are you getting what I'm saying? This is the most common mistake in DODB template. What I'm doing? From 3 people, you select one person. To that person, you give 2 cards. For that person, you select 2 cards. Is this clear? What I am doing, is this clear? Like this most common mistake. This is wrong. This is wrong. But is this clear what I am doing? This logic, is it clear? Like, okay, I am selecting from these 3 people, I am selecting one person, and to this person, I am selecting one person. To this person, I am giving 2 cards. Then from the remaining 2 people, I am selecting one person and I am giving 2 cards from the remaining 4 cards. From the remaining 4 cards, I am giving 2 cards. So what is the mistake here? Anyone want to tell me? Is there any mistake here? Yes, overcounting. So what you have done? You have done overcounting. Why you are doing overcounting? Can anyone tell me which case you have counted 2 times? Like you have done overcounting. For example, consider this case, X, Y, Z. Okay, where X is taking AB, this is taking CD, this is taking EF. This case you have counted. This case you have counted many times. This case you have counted. This case, how many times you have counted this case? Can anyone tell me? Just think about it. How many times you have counted this case? This case, okay, let's check. See, this case you will count when you select these. From 3 people, you are selecting one person. Can I select X? From 3 person, this is your formula. Okay, your formula is from 3 people you are selecting 1 people, then can I select X? Like count 1. So you can select X. First you select X because you are selecting 1 person. So you select X and you give 2 cards to X. You give 2 cards to X. Then from the remaining you select 1 person. From the remaining you select 1 person. From the remaining you select 1 person and you give 2 cards to him. And from the remaining 2 cards will give to him. So this is your count 1. The same case you can count. The same case you have counted like this. See, from 3 people you are selecting 1 person. From 3 people, so can I select directly Z? From, okay, you are selecting 1 person, right? Yes or no? You are selecting 1 person, right? So can I select Z? Can I select Z? Yes. And for this Z, you are selecting 1, so I can select Z. To this Z, I am giving 2 cards. To this Z, I can give these 2 cards. From the remaining 2 people, I can select 1 person, and to this person, I can give 2 cards. I can give 2 cards to this person. Okay, then automatically. So this is also, so how many times this has counted? Now tell me, this case you have counted 3 factorial times. 6 times you have counted this case. These are same, right? These must be same, yes or no? These are same distributions, correct or not? These distributions are same. So you can notice that this case you have counted 3 factorial times. This case you have counted. So this is the mistake. Is this clear? So don't do this. This is the most common mistake in DODB template. In the DODB template, this is the most common mistake. Let me tell you, don't make this mistake. Because it is a DODB template, okay, so all the people are already different. Visualize, do the visualization. In your mind, you think like this, okay, just think like this. In front of you, you have 3 people, 3 friends, XYZ. So there are 3 friends in front of you. Now what will you do? Now you want to distribute six objects, and in front of you, your 3 friends are sitting, XYZ. Then what will you do? To this X, you will give 2. Okay, first for this X, from these 6, you will select 2 for X. Yes or no? These 2 objects, you will select 2 objects. You will select 2 objects. You will give them to X. Multiplied by, from the remaining 2 objects, you will give them to Y. And the remaining 2 will automatically go to Z. This is your answer. Is this clear to everyone? Is it clear? So this is your DODB template. Okay, and DODB template is basically very simple. In the DODB template, this is your formula that if you have n people, okay, so this is the DODB template that total you have n objects, let's assume, and different objects and distinct objects, and you want to distribute them to k people and distinct objects to k people, and people are different. So these are your k people, like A1, A2, and so on, AK. These are your k people. And let us assume that you want to give N1 to him, N2 to him, Nk to him. These many objects. So total, what should be total? What should be N1 plus N2 plus Nk? This should be N. This is important. This is very important, that total must be N, because you are giving all the N to k people. So this total must be N. This total must be N. In this situation, answer will be what? How many ways? From N, you select N1 for A1. This is what you will do for A1. From N, you select A1 for A1. From N, you select N1 for A1. From the remaining, you select N2 for A2. You select N2 for A2. For A2. From the remaining, you select N3 for A3, and so on. Okay, so if you solve this, then you will get n factorial divided by n1 factorial, n2 factorial, n3 factorial, and k factorial. If you solve it, then this formula you will get. But the method is this. The method is very simple. Is it clear? So this is your formula. But remember, this is very important. N1 plus N2 plus Nk. This should be equal to N. Because if I give you this question, like 52 cards, and to give 4 people, 5 each. To 4 people, you give 5 each. Then many people, if you by heart the formula, then this mistake you will do. This mistake you will do if you by heart the formula. This is the problem with by hearting the formula. This is wrong. This is wrong. Why? Because this total is not equal to 32. This total is not equal to 32. But what you can do, you can do like this. These are the 5, these are the 4 people, 5, 5, 5, 5. And you consider one more person. Consider one more person. This one more person is your remaining. This is your, this is a pseudo person. This is a fake person or remaining. This is your remaining. Okay. Now you can do like this. Now answer will be 52 factorial divided by 5 factorial, 5 factorial, 5 factorial, 5 factorial, 32 factorial. Now the total is 52. Okay. So this is the idea. So this remaining you can give to this. So let's assume you have 8 distinct objects. You have total 8 distinct objects. And let us assume that, and let's assume there are total 4 people. There are 4 boys. To each, at least one you should get. Okay. So distribution, everyone should get at least one. Everyone gets at least one. Gets at least one object. Okay. So let's assume there are 3 boys, and okay, everyone should get at least 2 objects. At least 2 objects everyone should get. Then what is the answer? How will you do this? Everyone should get at least 2 objects. You have total 8 objects. Total 8 objects you have. 3 boys are there. Everyone should get at least 2 objects. So what will come to your mind for this question? Remember, in this, if you directly apply if you directly want to apply a formula, then this is Nk. Like Nk are going to Ak. This N1 are going to A1. So this is fixed. This is fixed. Now, how to solve this question? There is no fix here. Every boy should get at least 2 objects. So how to solve this question? First, you have to create cases. First, you have to create cases. There are 3 boys, A, B, C. There are 3 boys. 2 must go to him, 2 must go to him, 2 must go to him. But now 2 objects are remaining. Yes or no? Yes or no? A should get 2, B should get 2, C should get 2. Now 2 objects are remaining. 2 objects are remaining. So what I can do? 2 objects are remaining. So either those 2 objects can go to the same person. So there are 2 cases possible. Okay, there are 2 cases possible. I can do like this. Either you can do, either those 2 objects can go to the same person, or those 2 objects can go to the different person. Either those 2 objects will go to the same person, either this case or this case. What will be the answer for this case? Like one person is getting all the, one person is getting 4 objects. One person is getting 4 objects. So there are 3 people. From these 3 people, who will get 4 objects? Who will get 4 objects? Who will get 4 objects? First to decide who will get 4 objects. Yes or no? Yes or no? Is this clear? First to decide who will get 4 objects. First to decide this. For example, let's assume that this is decided that B will get 4 objects. B will get 4 objects. Now what you do? It is decided B will get 4 objects. So from 8 objects, you select 4 for B. For B. For example, B. Now you give 4 objects to B. Now very simple. From the remaining 2 to A. And from the remaining 2 to 4B, 4C. This is your answer. Is this clear? Very simple. See, first you decide who will get the 4 objects. Who gets the 4 objects? So for example, B will get the 4 objects. So 3C1. This 3C1, who decide who will get 4 objects. If B is getting 4 objects, so B should get 4 objects. So give 4 objects to B. From the remaining, you give 2 object to A, like this. What is the answer for this scenario? This scenario, you decide who will get 2 object. Yes or no? What will you decide? You will decide who will get 2 object. Sorry, who will get 2 object? Yes or no? Who will get 2 object? So this is what you will decide here. Like who is going to get 2 object? Gets a 2 object. So for example, B. Then it means from 8 you select 2 and give to him. From the remaining you select 3, give to other, and from the remaining you select 3, give to him. Okay, so this is your answer. Is this clear to everyone? Okay, let's see what is the okay, this method. What is wrong with this method? What is wrong with this answer? I am giving you answer like this. So what I do, to everyone I give 2, 2, 2. Okay, ABC, I give 2, 2, 2 to everyone. So basically, to everyone I directly give 2, 2, 2. Means from 8 I give 2, 2 for A, and okay, from 6 I give 2 for B, and I give from 4 I give 2 to for C. Now the remaining 2 people, now the remaining 2 objects, for every object we have 3 choices. For every object we have 3 choices. For every object we have 3 choices. Okay, so here to A or B or C, to A or B or C. When you see this template, when you see this, what comes to your mind? The remaining 2 people, the remaining 2 objects, they can go to A or B or C. What is this? This is your same most common mistake, because you are considering A, again you are allowing A, again you are allowing A, you are considering B, again you are allowing B, you are considering C, again you are allowing C. This is your most common mistake. This is the most common mistake. Do you remember? I told you the most common mistake in discrete in combinatorics. This is the most common mistake. Here you are doing overcounting. We have already seen this. Please don't make this mistake again and again. I promise you, no one will tell you all these common mistakes everywhere, in every scenario, in every type of question, in every tool. What are the common mistakes that students are making? No book will tell you. These are observations. I have made these observations by looking at the students, that students are making this mistake. Then these observations I have created. And I found that this is the most common mistake that students are making. So I am telling you, we have already done the complete analysis of this. See, when you see this scenario like 4A, and again you are allowing ABC, again you are allowing ABC. Yes or no? This is the problem. Yes or no? Is this clear? In this most common mistake, do we undercount, overcount, or like, is every valid case counted? Tell me. In this, is every valid case counted? Yes, every valid case is counted. This is exhaustive. Every valid case you have counted. So this is exhaustive. But you have counted more. Okay, so this is overcounting. So this is the most common mistake. Please don't make this mistake again.